Hi, everyone. This talk would be about content security policy. Content security policy is a defense-in-depth mechanism against cross-site scripting vulnerabilities. So it's a web defense-in-depth mechanism. And we at Google spent quite a long time perfecting it. We actually worked on the standard with W3C and with Chrome and with Firefox and other major browsers. In this talk, I'd like to just present basically a wrap-up of what 3 years of work have been, what are different types of CSPs and how you can adopt them in a safe way, which is actually really hard. And finally, some data of 1 year of XSS vulnerabilities reported to Google. And for the first time, we can show how many of them got mitigated by CSP, so how effective was CSP in the real world. I mean, we have, of course, Google as a reference, but we have dozens and dozens of services with very high traffic. So it's a story, and I hope you like it. So very quickly about me, I work in Zurich, Google, work mostly in web security, and so in the first part of the talk, I'm gonna give a little bit of an introduction, like what is CSP, what is cross-site scripting, and why it is still an issue. Sometimes we hear XSS is no longer as much as an issue as it used to be. There are many things that can help against XSS, fight XSS. This is true, but it's very much still an issue, and we'll see why. Then, as I said, some stats. The building blocks of CSP, how to roll out an effective CSP, and finally some advanced CSP kung fu that we never shared externally. So you can do some pretty wild things with CSP using it in an advanced way. And you can also have fun, and you can also screw up. So what to do, what not to do. And the very, very last thing is how to productionize it, so basically to deploy it into production to billions of users, and how to monitor violation reports, and so on. So if you, maybe it's not the first time you've followed me and Lucas. By the way, this talk is by me and a colleague, Lucas Weichselbaum, who couldn't be here, but he loves Hack in the Box very much. We're here every year, so also send him his greetings. And let's start. So we have a vulnerability reward program at Google, and all the rewards we've given, 2/3 approximately are web platform bugs. So web vulnerabilities dominate our reward pool. This is a little bit unsurprising, mostly because Google is chiefly a web company, even if we do other things too. Drilling down, like in these web vulnerability bugs, web platform bugs, we see that XSS accounts for 3/4 of those. So we have this figure, but it's not only Google. Also, HackerOne, you can see that they list cross-site scripting as their top vulnerability type. And also Mozilla, it's definitely their top vulnerability. So here, I like to argue for a moment for the need for defense in depth. So, as we say, the vast majority of application vulnerabilities nowadays are web platform issues. XSS is still an issue. And the problem here is that the web platform is not secure by default. The web platform still is not as mature as to have really secure by default primitives and APIs. So you can introduce XSS vulnerabilities if you use, for example, JavaScript DOM APIs, or if you use frameworks. Especially for sensitive application, for this reason, it is important to adopt defense-in-depth mechanism such as CSP in case the primary security mechanisms fails. And here, even before talking about CSP in particular, I'd like to spend a moment distinguishing between a good mitigation and a so-and-so mitigation. So we hear about mitigations in many ways. There are some people that advocate for them. There are some people that just hate them and say that they are just raising the bar. So they're just making exploitation more costly, but they're not solving the underlying issue. So everyone here as a point, what I'd like to distinguish here is that it's true that there are some mitigations that their only aim is to raise the bar. So they have an economy of cost in mind. They want to increase the cost of an attack and slow down the attacker. So CSP, as it was around 3 years ago, mostly whitelist-based CSP, where you had to come up with a list of origin from which you sourced and executed resources, was pretty much in this category. Like the actual sink is not closed. The attacker just needs more time to find a bypass on that whitelist. And that was very hard to do, and that's why CSP was not very useful at the time. And we had a paper on this. It is in the next slide with some references. We can also put some mitigations from the binary world, from like a memory corruption word here. They just slow down the attacker. One can say, for example, that I don't know, like DEP or SLR are in this category. A better mitigation is the one that also reduces the attack surface. So by doing that, it creates a measurable security improvement. For example, if you disable part of an unsafe API and you make the web developer unable to use it, you are actually removing an entire class of attack vectors. For example, if you do not have unsafe inline or unsafe eval in a CSP policy, you cannot use eval, which is an unsafe primitive. And basically, by doing that, you are actually hardening the code. So the modern way of using CSP also induces hardening steps that do reduce the attack surface. And this is what a better mitigation is, in our opinion. For example, you need to refactor things, you need to use better coding practices, and also in case of what you will see we call nonce-based CSP, you are incentivized to use contextual templating systems that are like the best way to protect against XSS and not having the vulnerability in the first place. Before going into technical details of CSP, and would like to give you some data about Google. Currently, we have an enforcing CSP on 62% of all outgoing Google traffic. We are prioritizing by domain sensitivity. We have more than 80 domains at Google, and we have more than 160 services. So we have to prioritize, and for the very sensitive domains, we have almost 100% coverage. And of all the externally reported XSS in 2018, more than 60% were actually mitigated by CSP. Among the 11 on very sensitive domains, 9 were on endpoints that had CSP deployed, and of which 7 CSP successfully prevented exploitation. And among all the valid 69 XSS vulnerability on sensitive domains, 60% were prevented or mitigated by CSP. So these are the pie chart. You can say around 78% on very sensitive domains and around 60% on all the sensitive domains. And here is another visualization of 11, 9 had CSP. Of these 9, 7 got mitigated, and the rest could be covered by a more comprehensive CSP. And we'll see later what this means. So these were the causes of the XSSs that got reported to us. I think this is a particularly interesting pie chart. It's pretty hard to say what is the ultimate sink of an XSS vulnerability. So we just putting here what the how the reporter in his or her proof of concept actually exploited the vulnerability. There might be more than one. Sometimes the boundary is a little bit fuzzy. But basically, something very interesting is that using JavaScript URIs and inline event handlers and data URIs, for example, are already more than 1/4 of the things. This was a little surprising for us. For example, we were expecting more fancy, I don't know, evil things, but actually evil is almost non-existent. So this is pretty interesting because you see that actually even the most basic CSP you can apply covers these basic cases, like does not allow JavaScript URI, does not allow inline event handlers, and does not allow data URI or injection into inner HTML context, as you see later. So here is a not at all comprehensive table of like XSS sinks and what CSP, how CSP can help blocking them. So the important thing is a JavaScript URI, data URI, which is just a wrapper basically that specifies the content type and the code, and inner HTML content, which can be basically a pure reflection into HTML context or a programmatic DOM-based injection into the inner HTML property of a DOM element. They are all blocked if CSP lacks unsafe inline. So CSP can be relaxed, right? You can put unsafe dash things, and if you do not have them, your CSP is stronger, okay? So if you do not have unsafe inline, you cover actually a pretty large part of this part already. This is to say, you don't have to think, right, CSP is so hard, I can't deploy immediately the best CSP, so I will not do it at all. Actually, if you do even the simplest to implement, and we'll show later how to implement, you already cover quite a big part of the actual real-world XSS exploitation vectors. Then there is eval, that, as you know, it evaluates a string as JavaScript, and this is blocked by CSP if it does not have unsafe eval. Then there are injections into the text of a script tag or into the source attribute of a script tag, and basically these are taken care of by noncing or hashing, and we'll see later what noncing means, because this is our preferred way of doing CSP against XSS. And finally, there are some more esoteric way of exploiting some popular web frameworks, such as AngularJS. When I say AngularJS, I mean really AngularJS, not Angular 2, Angular 3, Angular 7, Angular 40. They like big numbers nowadays. So AngularJS is Angular 1, okay? It's these things do not happen with Angular 2+, because Angular 2+ has ahead of time compilation of templates, or at least this is how you should use it. We'll not go into details of these advanced techniques. Okay, so first thing, the first time you might have heard of CSP, you probably have heard it of a collection of whitelist. Like, you have to list all the origins from which you source basically resources, like scripts or styles or images. Here we're focusing on scripts only because we care about XSS. Also, by the way, CSP has evolved mostly as an XSS mitigation mechanism. It is not to be used, for example, against exfiltration, because it will never cover all the possible ways of exfiltrating content. So our advice is to use CSP against XSS, not for other things. You can use it, for example, to limit framing, but we advise against using it, for example, trying to do navigation Js, which are not possible, or, for example, like against exfiltrating content, because that's just not possible. Okay, so why not whitelist-based CSP? As the president says, it sounds like a good idea, but doesn't work. Okay, we'll be short on this. We have a paper, CCS ACM in 2016, that explains that more than 95% of the whitelists are automatically bypassable, so by an algorithm, right? And there's a research paper, and we have also a tool, which is a CSP evaluator, which we created to demonstrate. You just put your policy or your site, and it will tell you how your policy is broken. If it is a whitelist-based policy, it is broken, okay? It is breakable automatically in 95% of cases, and manually more than 99% of cases. Manually just means an engineer has to take a look for a few seconds to your policy, okay? So why? Because basically there are a few things that actually allow an attacker to use one of your whitelisted origins to just basically proxy JavaScript. And this is done through JSON-P endpoints or by just hosting some libraries that have vulnerabilities such as AngularJS. So for example, a very bad thing you could do is just whitelist a CDN. If you whitelist a CDN, you're 100% bypassable, like storage Google APIs or a CDN NiFi or things like that. Because the attacker just sources Angular and then puts a sandbox bypass. And then you have JavaScript execution. Even if your site didn't use Angular, okay? But you're whitelisting something that hosts everything in their sync. Okay, so I've been a little bit too long on this. Do not use whitelists, please. They do not work. They work just in very, very, very few cases. And also you do not have control of all the origins you whitelist. So you do not know if something has changed, more things are hosted under these origins you're trusting. So please do not use it. It does not work. What we suggest to use against XSS is the so-called nonce-based CSP. We talked about it in previous years too. You might have heard it. If it is the first time you're into CSP, I'll just go pretty quickly. So a nonce is an attribute you put to the script tag. Usually you can also put it to the style tag or link rel style sheet tag. And basically it's a unique per response token, or, well, cryptographic nonce, as it should be called. The whole point is that it is unguessable and it is unique per response. Okay, so it has to be generated server-side, a little bit like a CSRF token. And the idea is and you have to put the same nonce in a policy. So the policy is sent via an HTTP header. It will be content security policy : script SRC, nonce, and a nonce, which should be a base 64 encoded string. Not too short, otherwise brute forceable. And basically, only the scripts that have a matching nonce attribute will be granted execution rights. Okay? So basically, if the nonce is not right, and an attacker cannot inject a script tag because they do not know the nonce, because it is sent with the same response via HTTP headers. Okay? If it is correct, it's granted execution. If it's not correct, it will not be executed. If you also add a keyword that is called strict dynamic, which I and my colleague Lucas worked on in the last few years, strict dynamic makes adoption of nonce-based CSP a little bit easier. We'll see it later. Basically, what strict dynamic says is if you have a correctly nonced script and there, and that script dynamically creates another script and appends it to the DOM, will also allow the dynamically created script, because this is a trust propagation problem. We are explicitly marking as allowed the parent script, so trust gets propagated to the children. Okay, so this of course weakens a little bit the security guarantees, but basically the idea is if you manually bless your scripts, you are also trusting them not to include things that are vulnerable or they have XSS. And we see later a little bit more in detail. So adopting CSP is always a trade-off between the security guarantees, how strong it is, and how easy it is to deploy it, how much refactoring is involved, for example. And we like to say that there are many ways, you can have different types of CSPs, and they become more and more secure, like towards level 4, but they're also harder to implement because they require more refactoring. Okay, so the level 1 CSP is actually a very new way of doing CSP, and we'll talk about it later because it's really works with new Blink browsers, which is basically Chromium and Edge soon. Level 2 is what we always suggested, which is nonce, strict dynamic, and safe eval. Level 3 is dropping unsafe eval, so disallowing eval completely. And level 4 is like just using nonces, so without trust propagation. Okay, so we skip level 1 for now because it is very new. We put it in the advanced CSP section. So this is a pretty good CSP already. You can try to use. We think this is a good trade-off between the refactoring efforts and the covered sinks. So what you do is you put a nonce and you put strict dynamic unsafe eval. So unsafe eval just allows eval to work. Eval is used in places you would not expect. Sometimes frameworks use it to do module loading, so to load at runtime things. Sometimes they use it to parse things, and that's problematic. They should not do that. But basically, a policy like this, it's also important to remember to also put object source none and base URI none. Okay, object source protects against plugins, and base URI none protects against something that is called rebasing of script, of non-script. It's a little bit of an advanced topic, but basically just put it, please, because otherwise, if you have relative paths in the non-scripts, an attacker can just inject a base tag and hijack all your scripts. So you have to put it. I know it's a little bit hard, but basically the idea is this is one policy. You just put this. You don't have to come up with a whitelist. It is always the same. Okay. So this is very good, offers very good protection against reflected and stored XSS. Most of them are mitigated. There is very little refactoring required. Actually, you just have to get rid of inline event handlers, and you have to add a nonce attribute to the scripts. It is particularly good if you also embed JavaScript that you do not control. For example, Twitter widget, Facebook widget, things like that. It has excellent browser support. It's supported by all major browsers, which means Chrome, Firefox, Opera, all the Blink-based one, and Edge soon. The only cons is that eval sinks are not covered, and there is still a very small window where DOM XSS are not covered. So here is a handy table. It will block attacks that are based on JavaScript URIs, data URIs, inner HTML content, and inline event handler. This was already a pretty large part of the pie that I showed before. It will allow eval, and if the attacker is able to inject code inside a script body, script text, or in the SRC attribute. Unfortunately, this is not covered. And what is the refactoring you have to do? You have, as I said, you have to remove the inline event handlers, like there, the on-click. You have to actually factor it out, and doing add event listener, click that. And you have to add nonce attributes to script tags. Okay? Hopefully, a templating system will do this for you, right? You don't have to do it manually. And using a templating system is the best way, actually, to avoid having XSS in the first place. Okay, so even better is dropping unsafe eval. If you don't use eval, you just drop unsafe eval, and you remove an entire class of vulnerability that are the ones that use eval. So basically, you just drop eval. And it's like before, but eval is also covered, okay? Here I wanted to show how to refactor eval in one common case. So sometimes, especially for old browsers, it's a common pattern to eval a JSON blob, okay? Usually with parentheses. You can use JSON parse for that. JSON parse is faster and more secure, okay? So this is the only extra step of refactoring needed here. Okay, so here a very quick thing. If you don't like nonces, you have a static site, so you don't want to generate different tokens at each responses. You can also use hashes. So something actually pretty cool that we'd like to show is that since strict dynamic enables this trust propagation mechanism, what you can do is also have just one script block that is we call a bootstrapping script that basically loads all your JavaScript. And since it is a static content, you can hash the content between this script tag. And then you just put the SHA-256 of that and strict dynamic. Basically, all the scripts that are loaded by that script tag will work because of strict dynamics. So the trust will be propagated, and you can have this on a static site. You can have it on, on your desktop. You can have it. You don't need a server that generates random nonces. Okay, so this is as good. It's actually slightly better from a security point of view, but it's not always what you need. So we just wanted to mention nonces or hashes. These are hashes. Okay. Even better is dropping strict dynamic. So if you can, and you want to be really, really safe, you just put a nonce. So what you need to do is basically not only putting the nonce attribute to all your scripts, but you also have to make sure that all the scripts that you transitively load pass that nonce to the children scripts. So if you source, for example, some JavaScript you do not control, like widgets, for example, I don't know, Twitter, so on, you can unfortunately not use that because they will try to load their twitter.com something scripts, and they will not, usually not. There are more and more widgets and scripts are now nonce aware, so they will pass the nonce. For example, Google Analytics will pass the nonce, reCAPTCHA will pass the nonce, but others, including some ads, will not yet. So this is problematic. This is why we created strict dynamic, right? Because this was not possible. Now it is more and more possible in more places. So basically, this is better from a security point of view. It is as supported. Actually, it is more supported because strict dynamic is not supported in Safari. We will see that we designed this part of CSP so that it falls back gracefully, so it stays open, right? So if it will just not provide the security guarantees if the browser does not support, but it will not break your site, okay? But basically, this is also supported by Safari. So this is, you will cover the vast majority, more than 90% for sure of your browser traffic. Unfortunately, a more extensive refactoring is required. Okay, you need, as I said, also to all the JavaScript libraries and widgets have to pass the nonces. But you cover almost everything. You cover injection into the text of script. Well, unless you are blindly noncing all the scripts, right? So if you are noncing all the scripts without checking, and there is an injection there, that's not covered. But basically, a script cannot just load another script that you didn't foresee, because it will need the nonce, and you didn't pass it. And the same for SRC. So this is pretty good. Unfortunately, you need to, when you dynamically create a script in your JavaScript, you also need to do this line. It's not hard, right? It's just one line. It's set attribute nonce, and random usually is actually fetched from the parent script tag. Okay, so usually you can do document current script dot get attribute nonce. Okay, it basically propagates it from the script tag. Here I just put the string for ease of for didactical purposes. Also here, please remember to put object source none, base URI none, or self. And please check with the CSP evaluator. There will be links again if you want to check your policy. So briefly here, we haven't presented level 1 and level 5, and we haven't talked about trusted types yet. So maybe let's focus on level 2 to level 3, level 4. This is a pretty extensive table that wraps up. So as you can see, there is even easier CSP you can adopt, which is level 1, but it covers less thing. And there is a Kung Fu version of CSP, which is actually not one policy, but 2 policies, which is what we call level 5, and we'll explain later, that covers almost everything. Here I wanted to give a shout out to an effort some people are doing. Some are at Google, some are outside. It's called Trusted Types. The idea is to actually solve DOM XSS at a code level, basically making the browsers use some kind of safe types that are actually mandated when they are passed to potentially unsafe DOM APIs functioned, or assignments like to inner HTML. This is a very promising effort. This is a hardening effort, if you will. It's a little bit orthogonal to CSP, if you will. In fact, for example, the protection in the first ones, it's limited to DOM XSS because that's what it's done. But if you want to search Google, Bing for it, it's trusted types. It's pretty cool. We suggest to use it in combination with CSP. CSP is like this second layer of defense. It's a safety net. Okay, so here's some more data about CSP coverage at Google. We are covering, as we said, approximately 75% of our traffic with the level 2 policy. And this was the policy that blocked around 60% of the XSSs, actually mitigated exploitation of around 60% of XSSs. So this is good enough, right? Level 2 is good enough. And we are slowly refactoring code to allow level 3 and level 4 policies. And here is a zoom. We have around a little more than 10%. Maybe now it's 15%, nonce plus strict dynamic without evil, and nonce only. Here are some domains to show you. We are at 100% coverage of CSP on very important domains. Accounts.google.com, that basically keeps your Google account secure. Chrome, that can install extensions in your browser, and other sensitive domains. Okay, so these are very high traffic. They're very complex services. Yes, it took some time, but it is pretty mature technology, and you can also adopt it in your web applications. And here's some more data, basically with a bar chart. And you can see that on very sensitive domain, we have almost 100% coverage. And here I'd like to go into the guru section quickly so that we leave some time, hopefully some good time for questions. I'm really looking forward to having questions from you. I know this is a very technical and there's a lot of data, but by all means, please reach out to me. Also, my colleague, there are our contact details later. We really love to receive questions and answer the best we can. So please don't hesitate. Okay, so the specification of CSP is an evolving draft, and there are more and more keywords and directives that are being added. And mostly they are for easing the adoption of CSP. So they are usually relaxing properties that actually relax a little bit the security guarantees, but also allow a much easier deployment. So one of those was strict dynamic, but there are also new ones. And two of these are script SRC LM and script SRC attr, that stands for attribute. So basically, the LM applies to the inline script blocks and all script requests, but doesn't control attributes, while the attr controls attributes. So what I'd like to show is that you can use this to limit the need for refactoring of inline event handlers. And here, finally, we are to the level 1, the most, let's say, least secure but easiest to implement. So this was not possible before, like a couple months ago. So basically, it looks a little bit longer and more difficult, but actually it's not so hard. Basically, what you can do is whitelist via hashes inline event handlers. So there are some websites for which it is hard to refactor inline event handlers. Maybe they have, I don't know, on submit return false, or very, very lame things like JavaScript void 0. We found these anti-patterns. They're bad coding patterns, but they're very, very common and actually do not pose a security risk. So the idea is we can actually allow, by hashing them, some of them. So by doing this, like basically having a strict dynamic plus unsafe eval, like a level 2 policy for the blocks, like LM, but also allowing some inline event handlers, the refactoring required is limited to just adding the nonce attribute to script tags. You do not have to refactor your JavaScript URIs. JavaScript URIs, by the way, are the same as inline event handlers for CSP. They are governed by so-called unsafe inline. Here you don't see unsafe inline because there is unsafe hashes plus hashes. So it is an unsafe inline that is limited to the ones that you hash. So for example, here you have JavaScript voice 0, you hash it, and you put it there together with unsafe hashes. Also this onClick, alert clicked, you put it there. So here the idea, you just nonce the scripts. This is actually pretty good. The only thing that makes it a little bit less secure is that if you have actually a lot of inline event handlers that an attacker could execute in sequence to do something meaningful. Like, for example, you have one that withdraws money and the other, well, you should not, right, have it as an inline event handlers. But the idea is, since you are whitelisting them by putting their hashes, an attacker can inject a script tag that does exactly and only that code. So an attacker can create some kind of gadget chain, like a ROP style gadget by putting different allowed pieces of JavaScript in a chain. So this is pretty advanced, but this is something to keep in mind. This is what is being relaxed by this. And finally, let's take one of the best, like the level 4 nonce only scripts, policy. Script SSC nonce with the object and base. What if you also put a whitelist-based policy which says script SSC self? So you put it on 2 different HTTP headers or on the same header with a comma. I know it's confusing that there is a semicolon for CSP syntax and a comma, but a comma in the value of an HTTP header is HTTP syntax. It means it is the same header another time. Okay, so for simplicity, let's just think it as 2 separate headers: content security policy script SSC nonce and content security policy script SSC self. So if you have 2 CSP policies served in parallel, every CSP is enforced independently. So a script is granted execution if and only if it passes both CSP. Okay, so the idea is this allows very, very advanced setups. For example, you can, have the nonce-based security and also limit the origins. So, for example, let's see an example here. You have a same site, inclusion with the correct nonce, fine, it satisfies both. You have an unnounced one, but on the same site, it is not allowed because the nonce-based policy will block it. You have a correctly nonce, but cross-site, you didn't expect it. Your developer, for example, adds an external script. Well, it is blocked, so it will not work. So independently evaluating 2 CSP policies is very, very powerful. You might want to keep this into account. You can do some very, very cool stuff here. And this is the level 5, the double policy, whitelist plus nonce only. So you might wonder, but weren't whitelist always bypassable? Yes. But here we're not using whitelist against XSS. We are using whitelist together with the nonce-only, nonce-based policy. So the nonce-based policy is the one that provides security against XSS, protection, while the whitelist is only an extra condition to basically breaking when something is not as you would expect. So for example, do you have all your JavaScript on your assets.site.com? Great, put nonce only and then put also script SSC assets.yoursite.com. If you put only assets.something.com, if you host Angular or something, you will be bypassable. So your CSP gives 0 security. If you put both, you do not have the usual whitelist bypasses because the nonce-based policy will take care of that. So in brief, everything is covered with the L5 policy, which are 2 policies. I know this is very advanced, but you can consider it, especially if you don't have a very, very large property. This might actually work for you. Okay, so quickly, if you follow the the nitty-gritty and like the fancy new attack vectors in the web security world, you might see some cool demos of how powerful CSS has become. And that CSS3 you can do, you can do cross-window things. You can play the game of life and do very, very, very cool stuff. So the idea is, you can have some of the effects of an XSS vulnerability even without JavaScript. Okay, just by using CSS. So for example, you can create some kind of CSS keylogger with only using CSS3 properties. And there is also a very nice write-up about using actually at import and time side channels to actually exfiltrate content 1 byte at a time. This is pretty cool. These are the so-called post-XSS vulnerabilities. So once XSS is solved, an attacker might want to use CSS to pwn you. Can CSP help with this? Actually, yes, there is a directive called style SRC where you can nonce exactly the same as with the script. Can be combined with script SRC. It requires, of course, refactoring of style blocks. But we are not pursuing this now because we feel that these attacks are almost always theoretical. Sometimes they're very slow. But they exist. So maybe in the future, this will become the next thing. And you might want to read this up. You will see from the PDF of these slides. So the very last thing. So CSP has a reporting mechanism. So when you deploy CSP like to your staging environment or so, you want to see what gets blocked by CSP if you are accidentally breaking parts of your sites on particular flows and so on. So the idea is if you put a report URI directive, the browser will send so-called CSP violation report to your endpoint. They will be basically JSON blobs, and they will say, you can see one here, what has been blocked, what was the directive that blocked it, and so on. What we suggest to do is also add report sample in the policy. The only thing it does is it instructs the browser to also include the first bytes of the blocked script. This is I think it is 40 bytes, so it's very little. It's very useful because most of the CSP violation reports are noise. They are due to extensions, browser extensions, or antivirus software, which is indistinguishable from malware, by the way. It's very hard to say what security software, when is a security software or when it is malware. So you will see basically if it is your code that's been blocked or something that is injected by something else. So for example, if you see, I don't know, LastPass, something, you'll see that it's an extension. Unfortunately, that is not playing nice with your CSP. Usually these are bugs on the extension side. And it was worse some time ago. Most of the popular extensions are now compatible with CSP. But this is very useful. I actually went through millions and millions of CSP violation reports, and it can be very frustrating, and this was a major breakthrough to actually make them useful. Not only that, with CSP reports, you can also see if you are able to reduce the noise. You can also see your exploitation attempts. So if the noise ratio, the signal to noise ratio is high enough, you can actually see if you are there are actually vulnerabilities that are being exploited and attempts to exploit them, and CSP are blocking them. We actually have at Google some monitoring, and it happened that we saw some actually vulnerable endpoints that were being, someone was trying to exploit those XSS. They were being blocked, and we actually did not report to us, but we found it through CSP violation reports. So for the first time, it is, especially with report sample, it's possible to use CSP also as a detection mechanism, which is very cool in my opinion. Okay, so here I don't want to bore you so much because it's really complicated here. But basically, CSP, there are a few versions of CSP, and they are all backward compatible, okay? Except some very, 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 very small things that are not 100% backward compatible. The idea is, if you have unsafe inline and unsafe inline is not supported by your browser, if you have nonces or hashes and nonces are not supported by your browsers, then if you also put unsafe inline is ignored in presence of nonces, and it's here, it's shown. So actually, let's go with the level 2. Level 3, it was nonce and strict dynamic, okay? What you want to do to give one policy to all browsers is also add HTTPS, which allows all scripts sourced from HTTPS, which means all the secure ones, and unsafe inline. So this might seem a little bit weird. Why are you putting unsafe inline? So the thing is, for modern browsers, unsafe inline and HTTPS get ignored because strict dynamic drops the whitelist, which is HTTPS, and the nonce drops unsafe inline. Okay, but older browsers will not understand strict dynamic, but understand nonces. So they will allow every sourced script, so HTTPS will stay. And very, very old browsers will not understand anything modern, and they will just fail open, allowing everything. So it does not provide any security, but it will not break your site. Okay, this is the thing. So this is why we send non-strict dynamic and then HTTPS unsafe inline. Okay, it's not a useless policy. And once again, please use the CSP evaluator to check your policies, because you might have noticed, like, it's pretty complex. There are many things that can go wrong. Please use it. It's pretty easy and quick to use. And to wrap up, so hopefully there will be some time for questions. Nonce-based CSPs actually cover the classical reflected and stored XSS very well. So even if you use a level 2 XSS policy, like the ones with strict dynamic and unsafe eval, you will cover the majority of the things we have experienced at Google for XSS exploitation. So please do it. If you can, upgrade to Nonce Only. Just drop the strict dynamic and manually do set attribute nonce. This is even better. And finally, the usual warning, CSP is not a silver bullet. CSP is just defense in depth. You have to fix your bugs, okay? If you have an XSS vulnerability, please fix the root cause of the XSS vulnerability. Do not rely on defense in depth to save your butt, okay? It might work in some cases, but it is not a solution. It's not an excuse not to fix your bugs. Please use the CSP evaluator. And this is even more in brief. Please use that. And if you can, use that. Okay, and this is the best you can probably do right now against XSS. And there is some documentation we've put for on csp.withgoogle.com. It's not a phishing site, even if it looks a little bit with Google. It's owned by us. You can whiz it. Okay, and thank you very much. Here are the slides on speaker deck, and please feel free to ask us. Here's also Lucas, LW is Lucas, Mickey Spag, it's me. Ask any question you might have. Thank you very much.
Yes, thank you very much, Michele. Are there any questions? There's a microphone coming.
How often do I have to change the nonce value?
I can see you, sorry. Well, okay, thanks.
I'm a small one, yeah, sorry.
No, it's just, there's this very blinding light.
How often do I have to change the nonce value for it to make sense? With every request?
Okay, nonces have to be unique per response.
Per response, so yes. That means what do I do about caching JavaScript files? My source?
You can cache JavaScript files. The markup should not be cached, and usually is not. Okay, so basically, you can have your JavaScript cached on your assets dot, but in the HTML markup, you have to put a different nonce attribute in the script tag.
And the browser will not, I have a near single page app, it's 5 or 6 pages. If I jump to the next page, it will reload my JavaScript again, now with a different nonce, but the browser is intelligent enough not to load it again because it is already in the cache. Also, it is another nonce.
No, it will use the cache. Like, it will use the cache for the JavaScript file, but this protection is only on the HTML page. So basically, it will be an HTTP header on the HTML page and the corresponding nonce attribute in the markup. Okay, so it doesn't matter where the JavaScript is sourced from. The browser will use the cache as much as it can. So the only problem is if you have a completely static HTML page, or if you want to cache the markup itself, which usually doesn't happen, actually. It's very rare to cache the HTML. If you want to cache your HTML for performance reason or for usually performance reason, then you have to use hashes instead of nonces because the hashes do not change over time. So what you might want to use in that case is the 3.5, the ones with the bootstrapping, this one. Yeah. So SHA and strict dynamic. This, you can
I understood that. And the nonce-based one is, because if the browser caches it, then I have a cache poisoning problem eventually. That another site uses a good nonce and the next site uses that one.
So are you talking about some kind of reverse proxy cache, or are you talking about the browser cache?
The browser cache.
Browser does not cache HTML pages unless instructed by cache control public.
But with my JavaScript files that are the base of all my HTML sites, I normally use it that the browser caches it one time and
that's totally fine. The nonce is not in the JavaScript file. The nonce is in the HTML file.
I have to put, okay, fine.
We can talk later if you want.
Yeah, we do that.
Yeah.
I didn't understand it completely, obviously. And if I understand correctly, if I have multiple JavaScript files loaded by each other, then all have to reply with the nonce, with the correct one. So if I have ads, all the ads also have to include the nonce. Isn't that a privacy issue? Because the ads now can track the session very, very closely.
Sorry, can you say how you think it would be a privacy issue?
Because now all the ads will get each call with a single nonce. And can therefore eventually fingerprint or track my browser even better than they can.
Well, the nonce is meaningless, right? So it's not associated with the session. I mean, the JavaScript that you embed with by trusting an ad provider will probably be able to read your cookies and your local storage. So this is much more identifiable information that you put with I mean, it's the same as exfiltrating a CSRF token that you have on a form on the side. They are random, they are meaningless, and I understand what you mean. They could be used, but they are unique per response, not per user. So they will change in the navigation, you know. So I think you have worse issues if you do not trust your ad provider, because your ad provider can basically inject all the JavaScript they want in your origin. So they can, get your local storage. They can get your cookies. They can, get your form fields values. So but sure. If you are worried about having one more piece of random data that might give some kind of extra information, you might want to not use nonces and use hashes. Yeah. But I do not believe this to be privacy relevant, especially if you are using bringing as an example a ad provider that has unrestricted JavaScript execution rights on your page anyway.
And one last question. This report URL in the CSP, I can send my reports about CSP evaluation to any domain there.
Yes.
And my browser, can I switch that off in my browser?
The reporting functionality? Yeah. Well, this is so the server has to explicitly say report URI?
Yeah.
Okay. No, this is how CSP works, right? CSP cannot be. So it is the server that.
I fear that there are pages that use that to report my visits of the site to another with a malicious CSP value.
Well, but you mean the server has been compromised because it's the server that has to send
No,
that.
because I don't trust the server.
If you don't trust the server, you should not visit the site.
The server reports my visits to somebody without
I think there are some privacy
compromising my IP address eventually or whatever, yeah.
So there are so many exfiltration mechanisms, right, for that. But and you really, this is quite a convoluted one to leak things. But yes, some privacy-oriented browsers actually, and some extensions like uBlock, for example, or MeBlock, do try to intercept and stop CSP reports for being sent. So you might want to use that. You have to consider that by granting an extension rights to block a web request, you are making it very, very powerful. So you have to really trust the code. I mean, if it is open source, you might want to do that. Absolutely.
Thank you. I have another question here.
Yep.
Hello. Here.
Hey, where?
Here.
Hey.
Thank you for the talk.
Those lights are...
My questions might be going a bit outside of this. One of them is those hash-based values. Is that similar to sub-resource integrity? Is that kind of SRI inserted into CSP? Yeah, you can answer that one first.
Yes, it's the same hashing algorithm, basically. So SRI has a different aim. So SRI, you use SRI... So just a quick recap, SRI is sub-resource integrity, is when you add attribute to a script tag, usually sourced from an external server, usually a CDN, because in case it is compromised, so when you add a script tag to your website, you are from a third-party server, you are basically trusting that server not to willingly or unwillingly serve malicious JavaScript, because that is executed in your context. So like the previous question, for example, if you're using an ad provider, they could steal all your user data, right? And the same for CDN, this can be a problem. And it has happened that some CDN, so if you pwn a CDN, you can execute JavaScript code almost everywhere, right? This is very scary. So SRI has as an aim to actually check the content of the script, and you have in the HTML markup like this hash, and basically the browser checks if the hash, the expected hash actually corresponds with the real hash that actually got from the network, from the CDN. If it does, it gets executed, otherwise it does not. Yes, it is the same hashing. The aim is a little bit different, right? So for example, here it applies to inline event handlers. So it's something that is in the markup. It's not like sourced externally. So it even blocks the fetch, while otherwise it is a fetch, check hash, and then decide or if or not execute. And SRI and CSP should be used together, actually, if you do not trust CDNs. So it's very, very good, actually, to use a script tag and then a nonce and then a CSP, and then also use SRI. Because basically it's a slightly orthogonal, right? It's not for the same thing.
The second question was more like, there have been recently these attacks called web skimming, where attackers have either compromised the site or they've compromised the third-party provider of metrics, analytics, ads, or whatever, and they've used those to inject scripts into the checkout pages of e-commerce websites to steal the credit card or payment information data inputted by customers. There have been like the British Airways breach, the Ticketmaster, Newegg, and other websites, and these attacks have grown in number recently, many compromises, and some, depending on the method used by the attackers, some of the defenses could be SRI for cases where it's modified, the script injected by a third party is modified by the attackers, and those injected directly into the website. Can CSP be a defense, and to what extent and how? Because in my view, one of them would have been like the whitelist, prevent scripts loaded from external sources, but you have taken this much further and said that whitelists are bypassable.
Yes, so it depends how they are injected directly, right? So, for example, is the hacked server redirecting to an evil server and sourcing from there? In that case, especially a double policy with a whitelist would block that request from happening in the first place. If it is like from they are served from an allowed one, a whitelist alone will not help from
like they have a web shell on the server.
They have, sorry, what?
They have a web shell or a backdoor on the server and can modify files. They can modify the script and just insert another script tag that loads the malicious script from their domain, from a domain they control.
Okay, so you're assuming a full compromised of a probably blessed script. Basically, if you use nonces, you would probably put a correct nonce there because you assume it to be right. So you have to use sub-resource integrity for this. You have to use SSRI, or you have to use hashes in CSP. But what I suggest is to use, this is an orthogonal problem. You have to use nonce-based CSP against XSS and SSRI for, like, also if you do not trust a third party like this. Because these are actually two problems. Like, one is an integrity problem and the other is a cross-site scripting. So it's technically not a cross-site scripting, what you're saying, right? It is no alien markup is being injected, but third party is trusted that should not be trusted. So it is a little bit different. So if you use SRI plus CSP, it's great. SRI alone would also help from that. Yeah, that's it.
And
thanks for the question.
Yeah, give a warm applause for Michele.
Thank you.